problems using Leibniz theorem in today's class. So the first problem is by finding in two different ways the nth derivative of x raised to 2n, prove that 1 plus n square by 1 square plus n square into n minus 1 whole square by 1 square into 2 square plus n square into n minus 1 whole square into n minus 2 whole square by 1 square, 2 square, 3 square plus etc. So we need to show that this is equal to 2n factorial by n factorial whole square. What we do here is we will take the nth derivative of x raised to 2n in two different ways. One is using the usual differentiation and one is using the Leibniz theorem. Okay. So let's look at the solution. Now let us look at the derivative of nth derivative of x raised to 2n. Okay. നമ്മൾ first derivative എടുക്കുമ്പോൾ you will get 2n x raised to 2n minus 1. Then the second derivative is 2n into 2n minus 1 x raised to 2n minus 2 varum. Then third derivative എടുക്കുമ്പോൾ 2n minus 1, 2n minus 2, then x raised to 2n minus 3, so on. Okay. Now we need the expression for the nth derivative. So this is the first, this is the second derivative, and this is the third derivative. So the pattern of derivatives is in this form. But 2n ആയിരിക്കും ആദ്യത്തെ term, then 2n minus 1, 2n minus 2, and the product will be up to 2n minus നമ്മൾ ഏത് ഡെറിവേറ്റീവ് ആണ് എടുക്കുന്നത്. സെക്കൻഡ് ഡെറിവേറ്റീവ് ആണെങ്കിൽ മൈനസ് 1 ആയിരിക്കും വരിക, തേർഡ് ആണെങ്കിൽ മൈനസ് 2 ആയിരിക്കും വരിക. സോ nth എടുക്കുമ്പോൾ ഇവിടെ n മൈനസ് 1 ആയിരിക്കും വരുന്നത്. എക്സ് റേസ് ടു 2n മൈനസ് കറസ്പോണ്ടിങ് ഏത് ഡെറിവേറ്റീവ് ആണ്. ഫസ്റ്റ് ഡെറിവേറ്റീവ് എടുക്കുമ്പോൾ 2n മൈനസ് 1 വരും, സെക്കൻഡ് ഡെറിവേറ്റീവ് 2n മൈനസ് 2, തേർഡിന് 2n മൈനസ് 3. സോ ഫോർ n that will be x raised to 2n minus n. So we'll get 2n into 2n minus 1, 2n minus 2 to 2n minus n minus 1. So into x raised to n there. Now this can be put in terms of factorial. So you will have 2n, 2n minus 1, 2n minus 2, etc. And the last term here is 2n minus n upper n plus 1 x raised to n. അപ്പോൾ ഇതെന്ന് പറയുന്നത് 2n-ൽ 2n n plus 1-ൽ സ്റ്റാർട്ട് ചെയ്യുന്ന പ്രോഡക്റ്റ് ആണ്. സോ ഇതിൻ്റെ തൊട്ട് പ്രീവിയസ് ടേം എന്ന് പറയുന്നത് n plus 2 ആയിരിക്കും, then n plus 3, you have up to 2n. So this can be written as 2n factorial. So 2n factorial if you divide by n factorial. So 2n factorial എന്ന് പറയുന്നത് 2n തുടങ്ങി 1 വരെയുള്ള പ്രൊഡക്റ്റ്, n factorial എന്ന് പറയുന്ന n തുടങ്ങി 1 വരെയുള്ള പ്രൊഡക്റ്റ്. അപ്പം n factorial will cancel out from 2n factorial. So this will be the remaining product. So you can write it as 2n factorial by n factorial into x raised to n. So let us call this expression as 1. Okay. So this is one way of obtaining the nth derivative of x raised to 2n. And now let's use Leibniz theorem to obtain the nth derivative. So we need nth derivative of x raised to 2n. So we can write x raised to 2n as x raised to n into x raised to n. So this will give us the functions u and v. So by Leibniz theorem, the nth derivative will be un. So dn of x raised to n into un v varum x raised to n plus nc1 dn minus 1 x raised to n into the first derivative will be d of x raised to n, then nc2 d or n minus 2 x raised to n into d square x raised to n, sum is nc3 d raised to n minus 3 x raised to n into the third derivative x raised to n, so on it will continue like that. Okay. So let's now write down the derivatives. So nth derivative of x raised to n is going to be equal to n factorial. So nth derivative of x raised to n is n factorial. So first term becomes n factorial x raised to n. Then second term you have nc1 n minus 1th derivative of x raised to n is, so we will get n factorial x ആയിരിക്കും വരുന്നത്, and the first derivative of x raised to n is n into x raised to n minus 1. The next term is nc2. Now we need the n minus 2 derivative of x raised to n. So that will be n factorial x square by 2 factorial ആയിരിക്കും വരുന്ന n minus 2 derivative, and we need the second derivative. So second derivative is n into n minus 1 x raised to n minus 2, and the next derivative will be nc3 n minus third derivative ആണ് വേണ്ടത്, n minus 3 derivative. So that will be n factorial by 3 factorial വരും, x cube n into n minus 1 into n minus 2 x raised to n minus 3. So now we can see that n factorial x raised to n is common in all the terms. So let's take out n factorial x raised to n. So in the first term we will get 1, and in the second term we will get nc1 into n, then in the second term nc2 into n into n minus 1 by 2 factorial varum, then nc3 n factorial by 3 factorial n into n minus 1, sorry, n factorial go out, nc3 into n into n minus 1 into n minus 2 by 3 factorial varum, plus etc. So that will be equal to n factorial x raised to n. The first term is 1, and the second term nc1 is n. So I can write it as, ഇനി നമുക്ക് കിട്ടേണ്ട എക്സ്പ്രഷൻ്റെ ഫോം ഇതാണ്, n square by 1 square n square into n minus 1 square by 1 square into 2 square. So let us simplify in that form. So second term is n square, I can write it as n square by 1 square, and the next term is nc2 എന്ന് പറയുന്ന n into n minus 1 by 2 വരും, ഇവിടെയും n into n minus 1 by 2 ആണ് already. So that is n square into n minus 1 whole square by 1 square into 2 square, and in the next term nc3 is n into n minus 1 into n minus 2 by 3 factorial. 3 factorial എന്ന് പറയുന്ന 1 into 2 into 3 വരും, അപ്പോൾ എല്ലാത്തിൻ്റെയും സ്ക്വയർ റൂട്ട് വരും. So that is n square into n minus 1 square into n minus 2 square by 1 square into 2 square into 3 square plus etc. So call it as expression 2. So 1 and 2 both are expressions for the nth derivative x raised to 2n. So let us equate 1 and 2. So equating 1 and 2. So that gives n factorial x raised to n 1 plus n square by 1 square plus n square into n minus 1 whole square by 1 square into 2 square plus etc. So this will be equal to 2n factorial by n factorial x raised to n. So x raised to n cancel out. So we will get the required result. So 1 plus n square by 1 square plus n square into n minus 1 square by 1 square into 2 square plus etc. is equal to 2n factorial by n factorial square. So that is the required result. Let's look at the next problem. We are given y equal to log x plus root of x square plus a square. So we need to prove that a square plus x square into y2 plus xy1 is 0. To evaluate limit yn plus 2 by y. So let's look at okay, so let's find this expression. So we have y equal to log x plus root of x square plus a square. So differentiate with respect to x, so that will give y1 equal to 1 by x plus root of x square plus a square into 1 plus x by root of x square plus a square. We are differentiate ചെയ്യുമ്പോൾ. So when you simplify, you are going to get 1 by root of x square plus a square. So that implies y1 square is equal to 1 by x square plus a square. So therefore x square plus a square into y1 square is equal to 1. Now again you differentiate with respect to x. So we will get 2x y1 square plus x square plus a square into 2 y1 y2 equal to 0. The 2 y1 cancel out. So that will give a square plus x square y2 plus x y1 equal to 0. So that is the required expression. And now let us take the nth derivative. So apply Leibniz theorem. So we'll get a square plus x square into yn plus 2 varum plus nc1 2x yn plus 1 plus nc2 2 into yn varum. And for the second term, we will have x yn plus 1 plus nc1 1 into yn. So this is equal to 0. So upon simplifying, you will get a square plus x square yn plus 2 plus nc1 is n upon 2n plus 1 x yn plus 1 varum. And ഇവിടെ nc2 എന്ന് പറയുന്നത് n into n minus 1 by 2. അപ്പോൾ 2 cancel out. N square minus n then plus n. So this will give you n square yn. So this is the expression for y n plus 2 involving yn plus 2. Now let us write the required expression. Okay, let us now evaluate the limit.